Hello everyone, and welcome to Piping Soup to Nuts Part 2. Thank you for attending the first one if you did. If you didn't, the first one is available on our YouTube channel. Just go to YouTube and search cadtechnologycenter.com. Just to start off here today, we're going to talk a little bit about what Piping Soup to Nuts Part 1 went over. We went over a lot of the mechanical settings, a lot of different settings for pipe types, material types, fluid types, and how those affect the analytical properties of Revit. We also went over different routing preferences and pipe systems, so how to set all that up and use it properly. Again, if you have any questions regarding Part 1, you can always comment on the YouTube video and we will answer those questions. As far as today is concerned in this live webinar, again, if you go ahead and have questions, type them into the questions field inside your webinar browser, and we will get to those at the end of the webinar. And today, for Piping Soup to Nuts Part 2, I want to cover a little bit about visibility. So we're going to look at filters, and we're going to look at templates and how that can all be applied to pipe and used to quickly create views for you, just so you can see what you want to see. And then we're going to get into some fittings, and we're going to look at lookup tables and how those lookup tables drive the fittings and the relationship there. We are not going to get into family content creation. That is a completely different webinar. Those of you who have explored family content creation know exactly what I'm talking about. But we will get into how we can modify lookup tables and modify fittings to make them more accurate. And then we'll get into some other options. A secret set of tools, I shouldn't really call them secret, a set of Revit extension tools rather. These Revit extension tools have been out for, since 2012. And they are buried all the way inside of some of the structural tool sets that are out there. But there is one specific tool that is very helpful to a lot of piping designers. And then if we've got time, we're going to get into some best practices and hopefully some schedules here by 12:30. So we're going to go ahead and, 12:45. So we'll go ahead and jump in right now. I'm going to go ahead and start with visibility and graphics like I talked about. Right here, you see a building in front of us. This building is complete with mechanical design as well. You can notice some rooftop units up there, some vent pipes poking out. But we're going to go ahead and we're going to go through some settings that allow you to filter out pipes. So starting with this view, we can see here inside of our properties, if we come down to view template, that there's no view template applied. When there's no view template applied, all old school, if you will, rules of visibility graphics control in Revit apply. Now, for those of you who may be new to Revit, if you come into visibility graphics here and you go into the model categories tab, you'll notice that if we simply use the model categories tab, that we can only shut off pipe accessories, pipe fittings, insulation, pipe placeholders, and pipes themselves. If we expand these options, you'll see that you can shut off individual elements that are associated with those categories. But if you were to shut off any of these individual elements, this is view-wide. So it begs the question, what do we do if we want to show a domestic water system and not a hydronic system on a plan? In order to do that, we would have to create filters. If I go over to my filters area here inside of my visibility and graphics, this is where we would see if we have any filters applied to this view. You can see here that I don't have any filters applied to this view. And so let's go ahead and explore what filters look like, what it takes to make a filter, and how we can use them in a view. So we'll hit cancel here. I'm going to go to my view tab and I'm going to open up my filters library. You can see here inside this project I have several filters already created for piping, duct, other system classifications. In order to get into where my filters are, I can just simply select one and hit edit. Now I'm inside my filters and I can choose which ones I want to edit just by simply going up and down this list. But I'm going to scroll all the way up to the top here. And I'm going to look at this first one labeled M Pipe System Compressed Air. I'm going to select compressed air, and as you can see, if I come over to my categories area and I scroll up and down, I have very few things checked that aren't, regarding to pipe. All my pipe systems are checked because I want this to be applied to all my different pipes. Next, you'll see the first filter rule that we have established. You see here that you can create several different filter rules depending upon your situation. But most firms are going to go ahead and just start with the system abbreviation equals and then the system abbreviation value. Now it's important to remember that this system abbreviation value, if I come over here to my pipe systems and I find my compressed air, I'm going to right click on it, go into type properties. That system abbreviation is right here inside of your system types. So when you're setting up your systems, this is why I mentioned that as an important rule inside of the first Piping Soup to Nuts webinar. We need to make sure that these are consistent, they're clear, concise, people know what they are, and we need to also maintain a standard, because if this changes, that means that this filter that we made, this compressed air up here at the top, won't work because that value is changed. So it's important that the system filters match the system abbreviation inside of each system. Otherwise, the filter applied obviously won't work because it'll be looking for different values. Now, setting up a filter is extremely simple. We simply come in here, we duplicate one that's existing, which get added down here to the bottom. Here it is, compressed air 1. We can rename it then. We can call it webinar filter. Oh, excuse me there. Little I. And click OK. Here it is at the bottom, stored as webinar filter. And obviously, since we duplicated it, it's going to take on the same settings as any filter we did before. This is a huge benefit when you're going through and creating your filters initially, because you can set up one piping filter, then your categories are all checked, obviously, and you can just simply move on to your systems abbreviation. Now you have a pull down here as to how you want to sort this information. So you could go ahead and create filters for all these different rules and any situation that you could possibly come up with. I totally recommend that you come in here and you play with some of these filters if you're not 100% comfortable with them. Obviously you have more parameters down here that you can check, and here's a bunch of additional parameters that you can sort by. So using all these different parameters, and of course you can make your own parameters that go into this list, you can really drill down and really fine-tune your views. So I'll just go ahead and apply that filter system abbreviation. I want to equals, and then I can make up a filter. Obviously this filter won't be applied to anything until I make a specific system for that, but this is just for practice to show you guys how this stuff works. So webinar filter here, so just WF, and then I can apply that and click OK and cancel out of here. In addition to those filters, we can take all those filters and we can apply them to view templates. So we could create all our filters and then create specific view templates for specific views. In order to check out our view template, I'm going to go ahead and go into the view template, and I'm going to click where it says none, and that should open our view template. And of course it's on my other screen. Let me bring it over here. Here we go. All right. Now you can see that we have some different view templates set up and created here for us. You can come into this dialog box and you can set up all your different view templates if you'd like. You can simply put this to all and then set up whatever view template you want, or you can do it by category. You can come into your 3D views, you can come and do your ceiling plans, along with elevations and sections, as well as floor plans and structural views. Right now I want to focus on our 3D views, simply because isometrics prove to be a challenge with a lot of what Revit functionality is set up for. A lot of piping designers would like to see better functionality there, and hopefully with the combination of some of these view templates and some of the tools I'm going to talk about in a minute, you'll be able to gain that functionality. So without further ado, I'm just simply going to come in here and I'm going to pick my plumbing riser scenario. You'll notice that when you select these view templates, all your visibility graphic settings are right here, included with other things, so like view scale, detail level, those sorts of things that you can set and have this be permanent. Now the advantage to view templates, if you don't already know, is that view templates can be applied to several different views or one view. But the whole point is that you have a standard view settings that can be applied to multiple views and adjusted once and then again be applied to multiple views. So you no longer have to go in view by view by view and change the visibility graphics to get the view that you're looking for. So I'll come into this plumbing riser here one really quick, and let's just check it out really quick for the filters. So I'll come in here and hit edit, and I want to see what filters are applied. You can see here we have many filters applied, and what's visible is checked, what's non-visible is unchecked. And you, in essence, go through once you've applied your filters here, which can be simply add, remove, and then you can go ahead and check your visibility. You can also override that visibility here. You can change those settings. But also in here you can do things like model category shutoffs, annotation category shutoffs, Revit link shutoffs, whatever you're looking to attain as far as the view is concerned. So I'll cancel out of that, and I'll show you the power of view templates here by simply going to my plumbing riser, and I'm going to go ahead and apply this view template to this view. Remember, this view has the full building and everything on it, and I'll click OK. Right now we have our plumbing riser, and this is including all our existing and all our new construction. We can also apply different filters or different templates here, excuse me. I'll go ahead and apply the domestic water riser template. I'll click OK. You see it changes to the domestic riser. And again, the vast majority of this is done with filters, not with model categories. Storm riser, click OK. So you know this is all in the same view and how quickly this changes. And then I'll go ahead and apply the waste and vent riser just to show you how all this can quickly be set up. So if you have these view templates already established, it's as simple as creating a view and then applying the proper view template, and then you get to see exactly what you're looking for. I'm going to go ahead and go back to this plumbing riser domestic water view template, and I'm going to apply that. So now we have our isometric. Now, as anybody who's used Revit for any period of time understands, is that when you model one element, it shows up in all the views depending upon what your visibility graphics are set up to be. The point being is that I model one element one time and it just exists inside the model. I can look at it in any view I want, and if I modify it in that view, it will modify it everywhere else. This leads to a lot of complications when it comes to isometrics for piping designers. Here we are in an isometric, and if I were to say these couple lines are a little too close and maybe I need to move them apart, if I move said lines, now I've updated the model. If I'm modeling this to show coordination, so I need to show where my pipes actually are, be it in a wall or in a chase, obviously I can't just grab these pipes and start moving them apart because that's going to affect my design. So we are looking for specific tools that will help us modify this. So the first step that I'm going to take here in creating this isometric drawing that's not going to affect my model is I'm going to go ahead and I'm going to place some tags. So I'll go to my Annotate tab. I'm going to tag by category, and I'm going to start, oh, that's right, I got to lock the view. My apologies, everybody. Baby steps, here we go. Give the view a name, click OK, and then tag by category. Now I can come around and I can tag my pipes. I'm just going to tag a couple here so we're not here all day. This one here, and a couple of these in this kind of challenging area where it's tough to get tags. Okay. Once my tagging is completed, I can go to an extents area of this view, just like you see here. And obviously you have lots of other stuff to tag here, and we could keep tagging for a while, but we're not going to in this particular situation. And then once I get my view to this position, I want to go into my extensions tab. Now some of you listening may not have this extensions tab. These are the tools I was speaking about in the beginning of the webinar. These tools are part of the Revit extension tool set, which is available on the Knowledge Network, but only to subscription subscribers to the Autodesk products. If you have a standalone license, you will not be able to access these tools. And as I said, they're the Revit extension tools, and the vast majority of these tools are going to be oriented around structural steel. But there is one tool in here that we can use to the huge benefit of plumbing designers, or piping designers rather, excuse me. As I said, these tools have been around for a while, but the more and more people I talk to who do piping inside of Revit are unaware that this tool exists. So I wanted to make sure that I showed you guys this tool for this specific webinar. So when I come into my extensions tab, I'm going to make sure I go over to the tools area. I'm going to hit the drop down here, and the tool I'm after is this freeze drawing tool. Now what this tool is going to do for us is this tool is going to look at this view and it's going to create a drafting view based upon the graphics in this view. So I can run this freeze drawing tool. Then I'm going to have the ability to select multiple views if I really want to. So this is a way that you could, say, create views for all your different type of isometric drawings if you wanted to separate out, say, your hydronic from your plumbing, or your domestic water from your sanitary sewer vent, from your rainwater leader. You could have all those views already set up and then just go into your selected views option, simply choose those views and click OK. For the purposes of this webinar, we are going to go ahead and use the current view. And I'm going to click OK. It may take it a moment here to go ahead and freeze that view for us. When it's done, it's going to tell us that it was complete and that it was successful. If I scroll all the way back up to my project browser, expand my views, I'll notice that here it is inside of my drafting views. I'll double click and I'll open that. So here we have that isometric in what is 2D Revit line work. As you notice now, as I hover over it, it is one big block. If I click on that block, I can use partial explodes, and I'll have to do this a couple times. So I'll use a partial explode here right away. Come back, click on it again, do another partial explode. A full explode is dangerous in this situation because depending upon how your families were built, it can delete elements on you. So proceed with caution if you use the full explode option. Now you'll see that I can select these lines individually. There's single line, like I said, 2D Revit line work. And so if I need to modify anything, I can do that. So if I want to go ahead and move any of this information, I can just simply select lines. And I understand that this isn't the most efficient way to go ahead and do that. We would like it if these things move together, but you can always do group selects as well, so you select both pieces of pipe and then do a move. Obviously you have to pay attention to what you're doing here because Revit understands connectivity, so it understands this line connection. You may have to unjoin some elements depending upon how far apart you want to place them, but this gives you the ability to stretch out an isometric without having to affect the model design. Also here we can change any of this because this is now line work as well, so I can do things like highlight here and use my move command to move this entire thing here on back onto that line. Okay, Revit still understands some basic connectivity with this line work, as you can see here and as you can see right here. So you may have to unjoin some elements to get this exactly how you want it, but this is a heck of a lot easier and better than exporting to CAD, re-importing. This allows you to keep everything as Revit line work and all native inside of Revit rather than having to maintain two separate design files. Another thing that we can do here before we create this view is to go to a a coarse or medium level of detail inside of that 3D view. So if I go back to that 3D view here real quick, I'm going to apply filter again. Let's go to domestic, excuse me, there we go. Come into this area, and rather than doing a fine level of detail, it's on the view template. Rather than do a fine level of detail, let's do a medium or coarse and change this all to a single line. And then I can do the same thing. I can export this out, or use the freeze tool on it to create that drafting view. I'll create another one for us. And that will all be single line work. So again, you're still here going partial explodes. Click on it again, do another partial explode. And here we can modify our line work. Obviously this is a little bit easier than having to modify a fine level of detail, simply because we're only moving one line per pipe, not two lines per pipe. Okay. Once again, that tool can be found on the Knowledge Network, or it can also be found inside the applications menu, or application exchange rather, excuse me, for Autodesk, but it is only available to subscription purchasers. Okay. So that kind of takes us through some design options that we can use. Once again, view templates are strongly recommended, not only by CTC, but by a lot of end users who use Revit, simply because we can set those up, we can have those be pre-established, and then have some consistency across project setup. So now that we've done taking a look at that, I'm going to go ahead and go into a different Revit project. And I'm going to show you guys an example of fittings and lookup tables and how a lot of that works. Here we are inside one of my test projects. Whenever I am creating fittings or modifying fittings, I like to establish a test project like this, and it usually is set up similar to something like this, where I have a test area to test the functionality. If you remember Piping Soup to Nuts Part 1, I'm really big on testing things once they've been established, just to verify that things are working the way they're supposed to. You always want to test anything you're building from a family perspective inside the project environment before you consider yourself to be complete, because ultimately that's what drives its usage, is its functionality inside of a project environment, not necessarily inside of its family environment. And so I'll zoom in here, and what you see is I've got some elbows here that I've been testing, both long sweep and short sweep elbows, some Ys, some double Ys, and down here in these areas I'm not completed with some of this testing. I use color controls to test and then verify, and if it's outside of the range that I'm looking for, I usually color that red so it stands out, so I know that that's something I have to come back and fix. So if you're going to do the workflow I'm about to propose, it's a good idea to have a test project already pre-established for that. And I just use simply reference planes to divide these things up. You guys can use model lines or not divide them up, however you'd like. But the whole point of a testing page is that I'm not just testing the functionality of one size, and this will make more sense in a minute when we look at the lookup tables. I want to test the functionality at each size. And not only the functionality, but the accuracy. I want to make sure that this is the size it's supposed to be. So, kind of go through lookup tables and show you how I started to do this process. I'm just going to go ahead and come into my Systems tab, and I'm going to grab a pipe fitting. See, I'm just grabbing the standard PVC elbow. This elbow comes out of the box, and it's been my experience that these PVC elbows are the more stable, one of the more stable rather, families inside of Revit. These fitting families seem to have the ability to not break as often as other families do. So I'll come in here, I'm going to place that elbow. I'm going to click on set elbow, and I'm going to change its size. Let's take it up to 6 inches so it's a little bit bigger, easier for us to see. Now, when I want to look at lookup tables, or I want to start exploring fittings, usually my first stop is with some sort of piping manufacturer to see what their size tables are, or some values that I might want to incorporate into this family fitting. In order to open these fittings in the family, you can either find the RFA file, which is hidden under program data on your C drive with your typical install, or you can just simply place it, click on the element, and hit Edit Family. This will open the element inside the family environment. For those of you who haven't been in the family environment, it looks very similar to a project environment in Revit, but your commands up here are different and they operate differently in a lot of ways inside of the family. Like I said earlier, we're not going to get into family content creation. But I would encourage you to just kind of, if you're going to do this, kind of peruse here, really see what's available to you as far as options, and gaining a level of comfort with the user interface that is given to you by Revit. If we come over here to the project browser, you'll see we have views, sheets, families, groups, very similar to the project environment. If I drop down and expand my views here, you'll see that I have different types of views, different ways of viewing this family that I've created. I'm going to start by going into the reference level of the views. Now the reference level of the views is usually a pretty powerful level because most content creators are going to be storing a lot of information here, and the information appears in the form of dimensions. Now these dimensions can be constrained and locked to in essence make the fitting flex to the proper sizes it's supposed to flex to, and it's going to pull those size values from the lookup table. Now if I simply just go ahead and change my scale here, let's say I'll go down to 3 inches equals a foot, it adjusts the annotation scale for those dimensions so that I can actually see things and read things. They're not all on top of each other. So it's always a good idea to come in here and kind of look at what some of these are. So here we have one that says socket depth. So we can highlight that dimension and we can look at what that's controlling. So I can see here, all right, this is controlling the outside of the socket and the inside of the socket. So this makes obvious sense that this is controlling the socket depth. If I look out here, I've got another one controlling this socket depth. Here I have one that's called length. I'm looking at that and it looks like it's controlling this center line to the overall end of this fitting, so thus if that is adjusted it would control the length of the fitting this way. And I bet you I've got another one, yep, right here, controlling the length of the fitting going this way. Now being this is a regular elbow, I would not be surprised if this length value here in the socket depth as well are all reading from the same spot on the lookup table. And then you have other various settings in here like angles, things that you that are there for the constraint to the geometry, but that you won't necessarily need to touch. We don't necessarily need to touch anything in here as much as we need to understand how this family was built. Here we have a center to socket bottom label, so we want to know what that value is because that's going to affect something. So it looks like this goes from the bottom of the socket to the center line of the pipe. We have some tick sizes in here for the actual 2D geometry that would show up on a coarse or medium level of detail inside a project environment, center radius controls, different things that we can peruse. This one area does not necessarily house all of the dimensions that you may need to know about, so it's always a good idea to check all these different views that are available to you to verify if you have any other dimensions. And the reason that we take some time to kind of review these dimensions is because we'll come over here and we're going to go into our family types. I'll click on my family types. And that is going to open the family types dialog box. Now inside the family types dialog box, you're going to be able to see what a lot of the settings are. So here we're looking at, we have wall thickness, tick size, remember that? We saw that dimension inside of our view. We also saw socket depth inside our view. You can see there's our length right there. All the parameters that are going to be contained inside this fitting that control its geometry are going to be listed here. They're also going to be listed with their default values and any equations that go into flexing that family. These equations are important simply because they are what drives the geometry and how it's supposed to flex and work. Again, this is family content creation, so we're not going to go too far down that road, but it's important for you to be able to say, all right, I found a length in there, so if I come to length here and I look, I can see the equation that drives that. So I can see that length is based on the center to socket bottom label times 1 plus the close angle plus the socket depth times the close angle again. And that is what's going to drive the actual size of that length. One of the biggest thing that we're going to talk about today though is going to be these lookup tables. So here we'll see we have a lookup table name, and the lookup table's name is Ben PVC Schedule 40 Domestic Waste and Vent. If I come over here to the right hand side of the screen and I go into my lookup tables, I have a manage button here. I'll click manage and this will allow me to look up my lookup tables. Now lookup tables previous to 2014 operated quite a bit differently. In 2014 we were given the ability by Autodesk to embed our lookup tables, which is what's going on here. We can import, export these lookup tables, delete these lookup tables. But we can import several different lookup tables here and then simply just change the name here to tell it which lookup table we want it to reference. So therefore, one fitting can do multiple tasks depending upon how we modify the lookup table. The same fitting, for example, could be Schedule 40 and Schedule 80 with just a different lookup table. So what I'm going to do right now, since I don't have this lookup table on file, is I'm going to go ahead and export this lookup table. I'm going to export it to my desktop, save it here, and then I'm going to go out to my desktop after that, so I'll cancel out of here, minimize both sessions of Revit, and that, and double click on my Bend PVC Schedule 40. So this is a lookup table. At first glance, it's a basic Excel document. Upon closer inspection though, you will note that it is a CSV file, and this is very important. This has to maintain a CSV file format. When you go to save this document in Excel, it's going to ask you, do you want to keep this as a CSV file format? You always want to click yes. If you click no and this becomes an Excel file, changing it back is relatively simple, but you may lose some data. So it's important to understand that we want to keep this as a CSV file. So here in the lookup table, you'll also notice that we have some abbreviations here. So these abbreviations are directly related to the settings inside of my family. So here I have socket depth. Now I can see that that's abbreviation is SDPT. So if I go back to my Excel file, I can find SDPT. So now I know that this value is what drives the socket depth. Note that I place that 6-inch fitting. Here's the 6-inch size in the lookup table. We have a 3-inch socket depth, and if I go all the way over to the right, center to socket bottom, which is the length, I'm going to see that that is a 5. So first thing I'm going to do here is hop back into my project. Come here. And I want to run a dimension. I'm going to run a dimension from the top of the socket to the center here, and I can see that that's 8 inches. Well, when I look back at my lookup table, this is a 5 and 3, that's 8. So this particular fitting is sizing properly. If I want to modify that value, it's as simple as opening up the lookup table. Say I'll change this 5 to 8 for now. I'm going to save that lookup table. Then I'm going to go back to my Revit family. Come back in here, go into the family, come back into my family types, go into my lookup table, manage. I want to re-import that file now that I've changed it and saved it. It's very important that we change it and save it, otherwise it won't update. Select that file again, click open. It'll ask me if I want to override this one that's already been applied. I do, and I want to click OK. Since the name of the lookup table hasn't changed, I don't have to come here and change it inside the lookup table name. If the lookup table name changes, you will always have to come here and tell it what lookup table you want it to use, and this typing has to be exact with the name of the lookup table. So it's usually a good idea to, say, open a quick little notepad, type that stuff out, so you can just do a copy paste into here. Now that I've applied that, I can just simply click OK. I'm going to take this particular family file that I have here, and I'm going to load it into the project. Overwrite the values, and you'll see it stretched to 11 inches. So 8 plus 3 is 11. This is stretching properly. And then you'll see also in the lookup table there's a lot of different values that you can go ahead and change. We can change ND, which would be the nominal diameter. We can change the angles to which these are constrained. We can change the socket end diameter. And the only reason I know what these guys are is because I've been spending quite a bit of time modifying lookup tables. Socket depth here, wall thickness, fitting outside diameter, and center to socket bottom. If you aren't familiar with what these mean and what they control, and they're going to be different for every family, guys. They're going to be different for a family you download off the internet. They're even going to be different for each family you open out of the box in Revit. So it's important to associate yourself with what these things mean, which is why I recommended that you open this up. You go to your reference view and you look at those dimensions and what they're controlling. Then also make a stop here and look at what some of those abbreviations might be standing for. It's really easy. You come here, you look inside of these calculations or equations here, and you'll find that. So wall thickness here, socket end diameter, or socket entrance diameter, excuse me, socket entrance diameter. And then you can verify what those things mean and what they control. And it's okay to do some testing here. Not every family flexes the way it was supposed to flex necessarily. So it's a good idea to come in here, play with some values, see what happens with the fitting itself, and then gain some understanding of how the fitting operates. This first column here, this A column, this is just for you to organize your information. Revit is not going to read this column whatsoever. It is, however, going to read this nominal diameter column. And this nominal diameter column is going to drive its ability to create anything. Say, for example, I were to go ahead and erase, well, I got a couple 1.5s here, so let's go to 1.5s, take all these 1.5s here, and I'm going to delete all of them. Now if I come back into here, I'm going to load this guy into the project. And now I'm going to come into my systems and I'm going to start drawing pipe. And I want to make sure I draw 1.5 inch pipe. It's still plugging in a fitting. So there's something else that is driving this, is perhaps the default lookup value in the family itself that is driving this one so that we can put it in. But normally when we do this in a lookup table and we were to erase these fitting sizes, it wouldn't be able to draw that fitting because it doesn't know where to look in the lookup table. All this information in a lookup table can be reorganized, it can be in order, it can be out of order, it really doesn't matter because Revit is going to be looking for the values that you have listed here. Obviously this gets a little more complicated when you get into other types of fittings, say upright wise or double wise, cross fittings, that sort of thing. There will be obviously more control there and then other equations that control other aspects of it. So a real quick and easy way, say for example, to get the Schedule 80 pipe up to where it is supposed to be for a fit from a fitting standpoint, because if you remember, if we go to regular out-of-the-box Revit, and I'll just close this for now, save it. Yes, yes, yes. Yes, yes, yes. If we go to out-of-the-box Revit and we look at pipe material types, so if we go into PVC, domestic waste and vent, type properties, routing preferences, segments and sizes, and we go to our material pull down, you'll see that we have a polyvinyl chloride rigid Schedule 80, okay? But there are no Schedule 80 size fittings inside of Revit. A real quick and easy way to get Schedule 80 fittings inside of Revit is to get a catalog for Schedule 80 fittings, sit down with the Schedule 40 family fittings that are available, and modify their lookup tables so that your Schedule 80 fittings are the same size as they would be when you install them, or if you pass it on to the contractor. He'll love you forever if you're an engineer because you've got the right size fittings in there. Yes. So now let's go back in. I just got a note from one of the viewers here that I didn't save the lookup table. That's a good catch. That's a good catch. I didn't catch that right away. Let me go ahead and hop back in here real quick. Now that I have saved that lookup table, let me go ahead and reapply it. Import, desktop, come down, grab this guy, open. Yes, okay. Okay, load into project, override existing. Still put it in there. Let's see if we can't draw 1.5 inch pipe and have that fitting not show up. Nope, it's still there. So again, I think a lot of this is being driven by the default. If I come back here and I click on this guy, you can see it's not the elbow that we're looking to have applied here. So let me try doing something else, because I bet you the routing preferences, yes, this is a routing preference that I have set up because I'm testing cast iron fittings right now. Let's go ahead and go to PVC, domestic waste and vent, where that elbow would be set up in the routing preferences. And it's still applying it. So this must be the default value inside of the equations. Okay. Holy cow, we took a half hour already, guys. Well, I apologize. It looks like I ran over here by about 10 minutes, so I do apologize if you guys had some place to be. That was really important. With this, I'm going to go ahead and conclude the webinar, and maybe I will talk to the powers that be and see if we can't get into a part 3 on this webinar, simply because we haven't really touched on slope pipe, best practices for that, workflows for doing pipe, as well as some of the functionality inside of actually drawing pipe. You notice when I activate the pipe command here, there's a lot of other tools for us to be able to use when it comes to tagging, not only tagging, but actually designing pipe. And I'd like to get into those with some of you and go ahead and explain how those things work and how you can use them to be more efficient in Revit. On a CTC note here, Midwest U is coming up. AU was a complete success. We learned a lot of great information, had a lot of great conversations with not only Autodesk, but a lot of other great users who educate us as to what they're trying to do, and just great knowledge all around. Midwest U would be a regional example of that, and enrollment for Midwest U is going to open tomorrow on our website. So if you're interested in attending a pretty good conference, we have 90 classes to offer, and all of them will be listed on the website that you can sign up for. Lots of different speakers coming from Autodesk, and industry leaders from all over the country are coming to Midwest U this year to help you guys learn a little bit more about what it is you do and maybe how to perfect some techniques that you're already using. So with that, guys, thanks for attending. I hope to see you all at Midwest U. I'll be teaching a class there called Revit Stump the Chumps. So if you're going to be attending Midwest U and you want to attend my class, please come with all sorts of questions so that we can go ahead and get all those Revit questions answered for you. So everybody have a great day, and we'll be talking to you soon. Thanks a lot.